Assalamualaikum and selamat sejahtera. So today we will discuss about business mathematics chapter 1, fundamental concept of mathematics under subtopic geometric sequence. So what is geometric sequence? Geometric sequence is each term is found by multiplying the previous term by a constant. So let's say we have an example of geometric sequence 2, 4, 8, 16, 32, 64, 128, 256. Then the rule for this term is Tn equal to 2 to the power of n. So in general, we can write the geometric sequence is AR to the power of 2, AR to the power of 3. So our first term is A, our common ratio is R. How to get the common ratio? Our second term divided by first term, or our third term divided by our second term. We should be noted here R should not be equal to 0, because when R equal to 0, we get the sequence of A, 0 and 0, which is not a geometric sequence. So this is example of geometric sequence. We have 10, 30, 90, 270, 810, 2430, which is our A equal to 10, R equal to 3. So by using the rule of Tn, so we get 10 times 3 to the power of n minus 1. So if we want to find the fourth term here, we just replace the value of n equal to 4. Then we solve for it, we will get 10 times 3 to the power of 3 is equal to 270. So if we want to find 10th term here, we just replace the value of 4 previously with 10. Because we want to find the 10th term. So T10 is equal to 10 times 3 to the power of 9. Which is the answer is 196,830. Okay, so the term in geometric sequence is Tn equal to AR to the power of n minus 1. We use n minus 1 here because for our first term, if we substitute the value of 1, n equal to 1, we will get AR to the power of 0. Our power of 0 is 1, then we will get the value for our first term is A. So let we have an example of geometric sequence 1, 2, 4 and 8. So our first term here is 1. Our common ratio here is 2. So we will get the sequence like this: AR to the power of 2 and followed by AR to the power of 3. So when we replace our A is equal to 1 and our R is equal to 2, then we solve for it one by one, then we will get the sequence is 1, 2, 4 and 8, like our given example here. So we need also to notify here that geometric sequence also can have a smaller and smaller values like this: 4, 2, 1, 0.5 and 0.25 and so on. So the common ratio here is 0.5. How we get 0.5? Our second term divided by our first term. 2 divided by 4, then we will get 0.5. So the rule for Tn is equal to 4 times 0.5 times power of n minus 1. So look at example 10 here. We want to identify our 11th term for the geometric sequence 3, 6, 12 and 24. So we know here the value of A is equal to 3, the value of R is equal to 2, which is R given T2 divided by T1, 6 divided by 3, then we will get 2 here. So the rules of any term, we know Tn equal to AR to the power of n minus 1. So T11, we just replace all the value in this formula. So T11 is equal to 3 times 2 to the power of 10. So we solve for it, we will get T11 is equal to 3072. So example 11, we want to find the 9th term of the geometry 81, 27, 9 and 3. So we know already here the value of A is equal to 81, the value of R is equal to 1 over 3. So we also use the rule Tn equal to AR to the power of n minus 1. Therefore T9 is equal to 81 times 1 over 3 to the power of 8. We solve for it when we will get T9 equal to 1 over 81. So the answer for example 11 is B, 1 over 81. So we want to find the first term of a geometric sequence is 5 and their sixth term is 160. So the question is what is the common ratio here? So we know A equal to 5, Y the system is 160. So T6 is equal to AR to the power of 5, which is 160. So when we substitute the value of A equal to 5 into our equation here, then we will get 5R to the power of 5 is equal to 160. Then R to the power of 5 equal to 32. So we solve for it, we will get R equal to 2. So answer for example 12, the common ratio is B2. Okay, so here we want to find the first term. If we are given the fourth term of geometric sequence is 27 and the seventh term is 1. So T4 is equal to 27 means AR to the power of 3 equal to 27, AR to the power of 6 equal to 1. So we have two equations here. So by dividing equation 2 from equation 1, we will get R to the power of 3 is equal to 1 over 27. Then we solve for it, we will get R equal to 1 over 3. So substitute R equal to over 3 into equation 1. Then we solve, we will get A equal to 729. So the answer for example 13 is B, 729. Okay, so this is how we find the formula for summation of geometric sequence. Okay, summation of geometric sequence is actually A plus AR plus AR to the power of 2 and so on until the end of the sequence is AR to the power of n minus 1. So let we multiply the first equation by R, then we get SR is equal to AR plus at the end of the equation is AR power of n. So let me put it as equation 2 here. So if we add up these two equation 1 and equation 2, then we will get like this. Okay. We subtract equation 1, we subtract with equation 2. So S minus S times R is equal to A minus A R power of n. At the center, we will reduce all this because we have the same value. When we minus, it will less, it reduce. Okay, so from here we summarize. Here we factorize this function, so we will get S bracket times 1 minus R equal to A 1 minus R to the power of n. So we solve for the value of S equal to A 1 minus R to the power of n over 1 minus R here. Okay, so that we put the summation notation here, which is sigma n minus 1 to k equal to 0 for AR to the power of k is equal to A times 1 minus R to the power of n over 1 minus R. This one for R less than 0. Okay, so for R, when R is less than 0, then we use this formula A 1 over 1 minus R. Okay, so summation for the geometric sequence is actually that we sum up all the sequence that we have in the geometric sequence. So the formula for summation of geometric sequence is A minus R to the power of n over 1 minus R. Which is A is the first term, R is the common ratio, and n is the number of the term. So R must be between -1 and 1. Okay. So R should not be 0 because when R equal to 0, we will get A00, which is not geometric sequence. So this example, if we have 1 over 2, 1 over 4, 1 over 8, 1 over 16, so we know our A is equal to 1 over 2, our R is equal to 1 over 2 also. Then we substitute all the information here, then we will get the summation of this sequence, geometric sequence is equal to 1, which is equals exactly to 1. Okay, so this example we want to find the first 5 terms, the summation of the first 5 terms. So we know the A equal to 10 or equal to 3 by divide second term with first term. Then we know we want to find n for first 4 terms. So we use the formula A times 1 minus r to the power of n over 1 minus r. So 1 minus 3 to the power of 4 over 1 minus 3. So that we will get 400 here. But if we use the manual calculation 10 plus 30 plus 90 plus 270, then we will get 400 here. Okay, this is an example of application geometric sequence in real life. Okay, so next is example 14. We want to find the sum of the first 8 terms of the geometric sequence for 5, 15 and 45. So our first term A equal to 5, our common ratio R equal to 3, our N equal to 8. Since we want to find Sn here, so S8 is equal to 5 times 3 to the power of 8 minus 1 over 3 minus 1. Then we solve for it, we will get our S8 is equal to 16,400. So the answer for example 14 is 16,400. Okay, so next we want to find the 9th term of the geometric sequence. We already given A equal to 1 over 3, then R equal to negative 1 over 3. Okay, by using the formula of N equal to A 1 over 1 minus R, because our R is less than 1, less than 0. Okay, so we just replace all the information that we have here, then we calculate, we get S9 equal to 1 over 4. So the answer for example 15 is 1 over 4. Okay, next we want to find the summation. What is the summation for the first 9 term? We have our first term equal to 20, R equal to 1 over 2, N equal to 9. So we use the formula as N equal to A times 1 minus R to the power of N over 1 minus R. Okay, so S9 is equal to 20 times 1 minus 1 over 2 power of 9 over 1 minus 1 over 2. Then we solve for it, we will get S9 equal to 39.96. This question want to correct to 1 decimal place. So the answer for example 16 is A, 39.9.